Welcome to my channel, The Discovery Desk.
When most of us picture a drone, we typically think of a little quadcopter dropping off a package. But a new class of military aircraft is built on a very different idea. It is designed to never come back. This shows what the military calls a one-way attack system. It's essentially a smart, flying explosive. It launches, cruises through the air to locate a specific target, and then detonates a 30-kilogram payload right on impact. For a long time, the standard way an army got their hands on these types of smart weapons was simple. They bought them straight off the shelf from other countries. But buying someone else's technology comes with a massive hidden risk. If a foreign manufacturer buried a secret digital backdoor inside the code, they could remotely shut down your entire fleet when you need it most. To eliminate that risk, the Indian Air Force took a different route. They tasked domestic engineering companies with building a completely new drone from the ground up entirely within India. Saying a weapon is secure and actually proving it are two different things. To guarantee absolute safety, the military forces developers through an extreme 5-step testing gauntlet. Step 1 is the supply chain X-ray. Before a single piece of the drone is built, the creators have to prove exactly where every ounce of metal and every wire came from. In this breakdown of the parts, notice the scan checking every component. The military placed an absolute ban on any materials originating from China. Even a single unverified screw or microchip could let an adversary hack the system. Next is Step 2, the brain transplant. The private companies building these drones have to open their doors and let military software engineers directly access their programming terminals. A specialized military unit steps in. They take the raw code and permanently embed highly secure, domestic encryption directly into the drone's processor. By carefully controlling exactly where the raw materials come from and writing their own security software, the military ensures the foundation of the drone is safe from outside spying. Step 3 takes things into the air with the Everest simulation. The drone must operate seamlessly up at 16,000 feet. Flying that high is incredibly difficult. The air up there is very thin, which means there's less pressure to push up on the wings to keep the aircraft flying, and less oxygen to keep the engines burning. If it survives the altitude, it faces Step 4, the blindfold test. The drone is sent on a live flight, but completely cut off from any remote control connection to the ground. This map shows why that matters. Enemies will try to blast the area with electronic noise to jam signals and confuse incoming aircraft. To bypass the noise, the drone uses internal navigation checkpoints to find its way entirely on its own. And if the mission is canceled or the target moves, the drone has a built-in safety loop. It automatically recalculates its route and flies safely back home. A drone that can navigate through thin mountain air and intense signal blocking guarantees it will complete its mission, even in the harshest environments imaginable. The final test is legal rather than physical. It requires the developers to hand over total ownership of the designs, basically the legal control of every blueprint to the military. This solves a huge problem called vendor lock-in. Usually, if an army wants to upgrade a basic part on a purchased weapon, they have to go back to the original corporation and ask for permission, which can stall operations for months. Because they own the actual blueprints, the military can adapt on the fly. They can swap out camera sensors, test new batteries, or rewrite the code instantly, without waiting for a corporate sign-off. Holding the source codes and patents means the Air Force maintains its agility for the long haul, entirely free from commercial roadblocks. This project leads to a bigger realization. Beyond manufacturing explosives, the real goal here is achieving complete control over their own digital tools. By demanding companies pass this rigorous gauntlet, India is actively building a robust, self-reliant network of local engineers and manufacturers. In modern warfare, a weapon's true value lies in who holds absolute control over its code.